Welcome back. In this video, we will finish our examination of the periodic table. We're going to discuss the classification of metals, metalloids, and nonmetals, as well as determine the predominant phase of each element. Now, we've already focused on the groups of the periodic table and identified most of the commonly seen elements, but there's another classification we haven't really mentioned yet. Remember, I just said elements are classified as metals, metalloids, and nonmetals. The majority of the elements on our table are metals. These include all of the elements in the first two groups except for hydrogen. They include all of the transition metals and all of my rare earth elements. Finally, some of the rest of my main group also count as metals. These include aluminum, gallium, indium, thallium, tin, lead, and bismuth. Hydrogen is classified as a nonmetal, along with all the elements in the top right-hand corner of the periodic table. The other nonmetals are carbon, nitrogen, oxygen, phosphorus and sulfur, selenium, as well as the group 7A elements, the halogens, and all of the group 8A elements, the noble gases. Now, there are 6 elements that I haven't actually mentioned yet that fall in between the metals and the nonmetals. These are the metalloids and include boron, silicon, germanium, arsenic, antimony, and tellurium. You might notice that they kind of make a diagonal line, and a lot of periodic tables will include a little zigzag to show you exactly where that's at. So why do we separate the periodic table into these 3 groups? Well, we do it because the elements in each group are known to have different properties. You may have already learned that metals are usually shiny, malleable, and ductile, or that nonmetals are bad at conducting electricity, but there are even more trends that we'll see in this group. All of the metals are known to lose electrons easily. In a later video, we're actually going to see that these metal atoms will lose 1 or more electrons, making them positively charged. Remember, those electrons are negative. You will also need to know the states of matter that elements tend to be in. All of our metals are solid under normal conditions with a single exception, mercury. Remember, mercury is Hg, and it's a liquid at room temperature. Now, the nonmetals are more varied in their appearance, but they typically hold on to their electrons more closely. In fact, it's more likely that a nonmetal is going to gain extra electrons, making them negatively charged. In addition, nonmetals exist in all 3 states. Hydrogen, along with nitrogen, oxygen, fluorine, and chlorine, as well as all of the noble gases, exist as, well, you guessed it, gases at room temperature. Bromine is actually a liquid, while the other nonmetals like sulfur are going to be solid under normal conditions. Now, the metalloids have some properties of both metals and nonmetals. However, they're all going to be solid at room temperature. Now, the atoms of the elements can be arranged in different ways, even in a pure elemental substance. So these arrangements are called allotropes. For example, with carbon, we say that if each atom is attached to 3 other atoms, we call this allotrope graphite, which is a black crumbly substance, and you use it when you write with your pencil. If instead each atom is attached to 4 other atoms, we now have a hard, colorless form, commonly called a diamond. Some elements normally exist in pairs of atoms. We call these the diatomic elements, using the prefix di for the Greek word two. Now, you will need to know all 7 diatomic elements, but you can use the periodic table to help with most of them. So make sure to highlight all of these elements. They include nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. You might notice that you just made a 7 on your periodic table. Well, these are most of the diatomic elements. The only one not in our 7 is hydrogen. Remember that hydrogen is the only nonmetal on the left side of the periodic table and likes to follow its own rules sometimes. Well, you will always have a periodic table available to you, including every single exam. You do need to make sure you know the names, symbols, and common properties of the elements in order to succeed in chemistry.